Good morning, 8th grade. This week is a little bit more of the same as last week. We're going to be working on our exponent laws, continuing to use those and get better with them and learn a couple of new ones along the way. So, without further ado, let's get into the video.
All right, 8th grade. Today we're going to be talking about a couple different exponent laws that we haven't discussed before. So today we're going to start off with the zero power. Now I'm going to try to show you a little bit of a proof into why our zero power law is what it is. So I know that a lot of you know that when we are dividing by the same base and have the same, or when we're dividing by the same base, we can subtract our exponents. So this is the same thing as 5 to the 1 minus 1, which is the same thing as 5 to the 0 power. Now, I know we're probably saying I don't know what 5 to the 0 power is yet, but let's think about it like this. 5 to the first power is the same thing as 5, so really I have 5 divided by 5 on the top and the bottom, or 5 divided by 5 total. And I know that 5 divided by 5 gives me 1. Therefore, that tells me that 5 to the 0 power has to be equal to 1. And that is essentially our exponent law right there. Any number to the 0 power equals 1. And that's essentially it. So any number to the 0 power is equal to 1. And that also goes for variables as well. If I have x to the 0 power, that is the same thing as 1. So let's do a couple of example problems. So I have y to the 12 divided by y to the 12. Well, I know that that's going to be y to the 12 minus 12, which equals y to the 0 power, which equals 1. Number 2, they've just pulled this apart a little bit, but I know that when I multiply numbers and fractions, I just multiply across the top and across the bottom. So I have 9 to the 15th, maybe if it wants to write for me, over 9 to the 15th, which equals 9 to the 15 minus 15, which equals 9 to the 0, which equals 1. Now I need to use my exponent law that essentially says when I have an exponent outside of parentheses, I need to distribute that. So first off, I need to do this inside of this parentheses right here. So I do that with the 4s. So I have 7 to the 4th and that number to the 4th. But then I also distribute my 0 in as well, which cancels everything out. So this is like 0 or 7 to the 0 power times 1, 2, 3, 4, 5, 6.789 to 0 power. So it's going to be 1 times 1, which equals 1. All right, so number 4 was already rewritten for us, but I know that this is going to be 2 minus 2, so it's 2 to the 2 minus 2 times 2 to the 5 minus 5, so 2 to the 0 times 2 to the 0, which is 1 times 1, which equals 1. And it's going to be a similar situation here, okay? I'm going to end up rewriting things because multiplication is commutative, so I'm going to be rewriting things as y to the 15th times x to the 41st over y to the 15th times x to the 41st. And then I'm going to break things apart. So y to the 15th over y to the 15th times x to the 41st over x to the 41st. So this is y to the 0 times x to the 0, which is the same thing as 1 times 1, which again my answer is 1. So that's just a bunch of examples there that show you that anything to the 0 power, any number, any variable is going to give you 1. So let's move on to another exponent law. So our definition: for any non-zero number x and for any positive integer n, we define as x to the negative n as 1 over x to the n. So this is essentially saying whenever we have a negative exponent, we make it the reciprocal, okay? So, for example, if I had x to the negative first, this is the same thing as 1 over x to the first. And I'm also going to challenge you in a different way, and I'm going to say if I have 1 over x to the negative first, well, that is the same thing as x to the first over 1. Again, it's dealing with reciprocals here, okay? So let's do a couple of example problems. So we're going to end up rewriting these, and we will go from there. So 5 to the negative third is the same thing as 1 over 5 to the third. 3 times 2 to the negative fourth. Well, this is like 3 times 1 over 2 to the fourth, which just equals 3 over 2 to the fourth. I'm trying to rewrite it in the opposite notation for exercise 9. So what I'm going to be doing is I am going to rewrite this as x to the negative ninth power, because that's the same thing as 1 over x to the ninth. Same thing for exercise 6. This is just going to be 8 to the negative ninth power. For exercise 8, I have x to the negative third. Again, this works the same for variables as well. So this becomes 1 over x to the third. And right here, let x and y be two non-zero numbers. I have x to the first. I'm going to rewrite this. That way it shows all of their exponents. I have x to the first times y to the negative fourth, which this just turns into x to the first times 1 over y to the fourth, which is the same thing as x over y to the fourth power. Let's do a couple more example problems, and then we'll be done with the video. So in this case, they are also saying that whenever we have a fraction with with an exponent outside of the parentheses, our exponent gets applied to each of the fractional numbers. So if I have 2/3 to the fourth power, I essentially have 2 to the fourth over 3 to the fourth. Okay, and they show you the proof for that all up here. So let's do a couple example problems and we'll be done. So in this case, they are actually just doing some further example problems for negative exponents, but they just want to show you that this was the case. Okay, so what I'm going to do is I'm going to simplify things first, and then I'm going to actually simplify just as much as I can. So this is the same thing as 19 to the 2 minus 5, which is 19 to the negative third. So that actually simplified is 1 over 19 to the third. There we go. That looks more like a 3 now. Finally, I'm going to use, for this one, 17 to the 16 minus negative 3. But when I subtract by a negative, that is the same thing as adding by a positive. So this is the same thing as 17 to the 16 plus 3, which is the same thing as 17 to the 19th power. And those are all of the example problems that I have for today. So feel free to watch this video as many times as you need to. Feel free to put a question in the comments down below. I'll make sure to answer. Feel free to send me a message on Schoology. Contact me however you want. And I will see you next time. Have a great day.